Good morning, everyone. My name is Roberto. I'll be talking to you today about a deep dive into database security. It was a different talk for me because I'm usually talking to DBAs and people who work with databases all day. So I worked the presentation up and then I can't assume people are DBA, so I had to go back and redo most of it. So it's been an interesting ride, but to give you, I mentioned for those who are coming in now, I have a QR code over there for you to download the presentation in case you want to follow along or, have it for later, so you can follow along with the links and, just don't go forward too much. But hopefully this presentation will give you some insights on what to do to secure your databases. There's a lot more to it than you think, but mostly because databases are generally very central to the architectures of applications and companies, and developers tend to just think it's that thing over there that I just connect to and I write stuff to it, and they don't really care much about it. But when it breaks, then they really care about it. So we'll talk about that. So a little bit about me. I've been working with databases for a long time. I went to Utah State with my good friend Dan there since those times, and I took an interest in databases since then, and it's been a great ride. So these days, I work for Crunchy Data. They're a company based out back east in Virginia. We have a lot of customers in the government space, all sorts of government agencies, but also we have a lot of enterprise customers. And I'll talk a little bit about Crunchy, but outside of work, I usually just do more tech stuff, Raspberry Pis and home automation, making sure that my network rack is good, and Dan tells me about his latest backup script, and I'm like, let me try that. And so it's usually more tech stuff, but I also have a life outside of tech. Snowboarding, I like reading economics, I like scouting, and I like traveling. So you can find me on Twitter, which I can't bring myself to say X, and LinkedIn. So any other Aggie out there besides me and Dan? Oh, there you go, awesome, cool. So I work with Postgres all day. I work with customers that are working with different databases all day, but we mostly focus on Postgres, and we help customers migrate, we help them run. But people ask, well, why Postgres? And Postgres it's become quite an interesting project for how many features it's had over the years, it's added over the years. I think it's up to 3.5 million lines of code. From, I think 10 years ago, it was 2.5, and now it's 3.5. So it's, for how many new features and new capabilities it's gotten, it's quite compact in its size. But besides all these features that it has, it's really become kind of a base for a lot of other products. I don't know if how many of you follow this space, but there are all sorts of other products that are based on Postgres now. They just take the core or take the things that Postgres does really well, and then they add some other thing. They tack some things into it. So Supabase, Yugabyte, CockroachDB, Google released AlloyDB recently. It's like their Postgres, but with their own storage layer that does auto replication and all those things. Let's see who else. Nile, some new company, Nile. It's a Postgres-based product. It was released, I think, yesterday. I saw that on Twitter. So it's become kind of this base for a lot of different products that do different things, like specific niches. So timescale is another one. There's a lot of them. So the project itself has become an umbrella. I wouldn't say, umbrella is not the right term. So it's become like a base that all these other products that are outside of the umbrella use. So it's quite interesting to see how it has grown. So Crunchy Data, a little bit, it's Crunch Data is focused on Postgres. That's all it does. It employs a bunch of the core contributors and some, not just for, okay, audio's back, okay. But also for a lot of the ecosystem products around it. So PG Backrest, Crunchy funds it. PG Monitor, it's a monitoring suite to monitor everything around Postgres. And different projects, but in Crunchy contributes to all those projects. They're all open source. All of our products are open source. Well, mostly. But it also sponsors Postgres-related initiatives in Kubernetes. It has a leading operator to deploy Postgres in Kubernetes, and it has a fully managed service as well. So if you need Postgres on the cloud, any cloud, without lock-in, I'll show you that in a second. So it takes Postgres, all the open source software, it does some certifications, it adheres to a bunch of common criteria, it packages, integrates it, documents it, automates it, and adds support into it, and then you use that as a Crunchy product. So it's basically enterprise-ready Postgres with open source software. So people ask, well, what do you add to the open source? It's still the open source product. We just add support and packaging and make sure everything is signed, and we certify everything, make sure everything works together with the right version. So, but it's 24/7 support, and our support is really, really good. And I can't say that about most support organizations. So, support-based organizations, I should say. So if you need to deploy Postgres on bare metal or VMs, we have products for that. You can do one command on Ansible and you deploy a whole cluster of Postgres and etcd and Patroni and everything around it. If you need to deploy Postgres on Kubernetes, we have a product for that. Our operator's really good. We use it every day. And I'll talk more a little bit about that later on. And we have our fully managed cloud service. So that's Crunchy Bridge, which for about the same price that you get paid for other cloud services, you get full super user access to your database, you get full access to the file system, and you get a really good developer experience with better performance for the same cost. So it works really well. It has great UI, and we've had lots of success stories with customers migrating from cloud providers. And you can choose, run on AWS, run on GCP, run on Azure. It works. And you get our support. So let's get to the meat of the presentation. So when we talk about a database, what we're really talking about is an advanced SQL front end to a file system. So you have a data access platform. Postgres moved beyond being just a relational database, and it's a data access platform, pretty much. You can have other databases accessing it. You can have it access other databases. You can have JSON. You can have all sorts of things. You can have AI. There's an extension called PG Vector that helps you do proximity and similarity to different words. So it's, with the explosion of AI, it's gotten a lot of adoption, and that it's improving really rapidly. And I think I can't remember the name right now, but there's a product that someone is making precisely around AI on Postgres, and using the Postgres data platform to, do the things that massage the data that you need in AI. So you have a file system, you have a daemon listening on a specific port, and then you have all these files. And these files are your data and your metadata for those in configuration, and you have transaction logs. And don't forget that you should really have backups. Most of the problems that I have with customers, so customers install and they deploy, and it's great. Like on Kubernetes, they can push a button and, oh, look at that, a server showed up and I can connect to it, it's awesome, yay. But they always forget to make sure they have storage for their backups. So their backups fill up, and then eventually the transaction logs They start accumulating. So Postgres has transaction logs. Every time you make a change, it writes that transaction log. If it can't back up, if you have backups configured, it keeps pushing those transaction logs out to wherever you have it. But if your storage fills up, then PG backrest in this case, which is what we use, says, oh, I can't push. I'll keep the transaction logs around, because otherwise your backups are really not valid. And then they're not monitoring, and then it starts filling up. Transaction logs, and then they run out of space on the main database volume. And then it stops working. Then we're like, why is it not working? Like, you run out of space. So don't forget your backups. So the backups are part of the database. If you don't have backups, well, then you're just being lucky. And you're lucky, eventually it will run out. I was going to give you an example, but anyway, so if you look at SS and you look at Postgres, if you search for the port 5432, it's usually the port that Postgres listens on. There's a daemon there listening, that PID. And if you look at where Postgres stores its files, that's what it looks like. There's a base, there's a global, all these folders are the database. So that PG wall, PG underscore wall folder there, this guy, well, never mind. I bought a laser pointer for this presentation, and it came in yesterday, and I forgot to bring it, so it's great. So PG wall is with the folder where Postgres stores its write-ahead logs. That's why it's called wall. So this folder used to be called PG underscore xlog for transaction log. And they renamed it, I want to say it was 3 releases ago, because customers, users, when they went into the situation, they're like, oh, we ran out of space. What do? We have to make up some space. Oh, there's this xlog folder here. Let's just delete everything. And then they just hose their databases. So they renamed it to PG wall so that wouldn't be the case anymore. I don't know why I had that. So that's the reason why it's called PG wall these days. But don't delete files in Postgres folders. Don't delete files. Just don't do that. That happened, I want to say 2 weeks ago. It was pretty much an all-day incident with a customer who went down and like, oh yeah, I deleted all these files. Like, oh, okay. Let's see what we can do. But once you delete those files, you don't have them backed up somewhere else, then it's pretty much data loss. So that's, backup software, it's going to take those files, ship them out, and then it can be removed from the main server. But if you're not shipping them out, then you can't delete them, or you shouldn't delete them. So database security, that's usually what we think about when we're talking about database security. Who can access the database? Who can authenticate the data to the database? What data can they access? What data can they change? Who did what and when to my database? How can I access my backups? And how can I recover when there's a problem? And unless you're extremely lucky, you will have a problem. But in my experience, eventually your luck runs out. So don't count on that. Although I'm saying that tongue-in-cheek because I know it happens all the time, like all the time. But the things were working, like, yeah, I know they were working, but at some point they stopped working. So a simple view that people think of databases, and developers usually think this way. So you have some applications or some users or other databases that are accessing your database. So your database is there listening on a TCP port, usually, and you have all these files around it. You have your configuration, your metadata, your actual data, and your transaction logs, the wall files. And that's how people usually think. Oh, it's just that port over there, and we talk to it, and it's okay. I have my driver on my application, and it's talking to it. But that's a simple view, and unless your application is, your use case is really, really tiny, like your home server, This is not how your stack's going to look like. If you want to run a production database in a production environment, then you need other things around it. And in the Postgres project, what it does, it says, we're not going to try to do everything for everyone. We're going to build infrastructure in the server, and then other projects can hook up into the infrastructure and build their things. That way we have maintainable software. Otherwise, you would have exploded by now, because it's way too many things. There's way too many. So a more realistic view, it's something like that, where you have your Postgres server sitting here, but then you have Patroni, which is a framework for creating Postgres clusters. So Patroni talks to Postgres, and it does all sorts of things to make sure that it stays up. Or if it's not up, like if your primary went down, I have to do a failover to my replica. So Patroni monitors that, and it talks to etcd. Where's my etcd? I don't have etcd. Here it is. Here's my etcd. So Patroni's talking to etcd, which has to be in odd numbers, so they can have elections. Everybody familiar with etcd? Anybody not familiar with etcd? Okay, so etcd it's a distributed consensus system. So it's really fast. You talk to it on a REST API, and you can write things to it, and it's durable. It's really, really fast, like milliseconds. And you usually have to have at least 3, and they keep talking to each other. They keep saying, somebody's the leader, and they say, I'm the leader. So Patroni, who's writing stuff to etcd, says, I need to update who's my primary. So my primary is over here, and he writes that to etcd. So it just goes to etcd and say, I don't care who the leader is, you guys figure it out. So, but etcd within itself, within its 3, it's saying, I'm the leader. Don't worry, it's me. But if that leader goes away, it disappears, then they hold a leader election and say, I'm going to put a vote, I'm going to put a vote. So they vote. Now, I'm the leader now. So they take care of that. So Patroni relies on etcd for its consensus. So you don't have to use etcd, but that's usually what you use. And Kubernetes itself uses etcd as well internally to keep track of its nodes and its stateful sets, all the stuff that it needs to write. So it's a distributed consensus system. So you need Patroni, and Patroni needs etcd, and you usually need some sort of, your application is talking to a load balancer, a connection pooler of some sort. So PG Bouncer is a good one. So it pools connections to the database. So just, again, I'm usually talking to DBA. So a connection pooler, connections to the database are kind of expensive. They take a little bit of time. So you don't want your application to open connection, do a little thing, get out, close the connection. Open a connection, do a little thing, get out. That's slow. Well, it's much slower than if you just kept the connection open. So in drivers, like in Java or .NET, and I imagine pretty much every language these days, they do some sort of connection pooling to keep those connections open. But there's dedicated software to do that. So PG Bouncer is one of them. It's an open source project. Crunchy has a bunch of developers on it, but it's really, really good. It's in C, it's small, it's tiny, and it does its job really fast. But it basically opens a bunch of connections to the database and keeps them, then your application talks to it. So your application thinks it's talking to Postgres, but it's not. It's talking to PG Bouncer, and PG Bouncer, when a connection comes, say, you authenticated, okay, let me hand you one of the connections they already have open, and it just does its job. And I should mention that in the latest release, which came out, I think last week, they added support for prepared statements, which is a really big deal for the connection poolers. That wasn't supported. So there's a bunch of work that has to happen for that to be the case. So besides the connection pooler, sometimes you have something like HA proxy, so that you can keep a virtual IP of, okay, who's my primary I need to write to? So it's that guy. But if there's a failover, I need to update who I point to, who my virtual IP points to. The primary went away, the replica now became the primary, now I point connections to that guy. So the HA proxy can do that. And Patroni and PG Bouncer can do that too, but some people want to do that transparently. So we have PG Bouncer and HA proxy, we have etcd, we have Patroni, you have Postgres. You usually want some sort of monitoring solution if you don't have one. So you have a Prometheus exporter, you have a Grafana to do your dashboards, you have Alert Manager to do your alerts, and all of that, you have some sort of storage somewhere, and you have PG Backrest doing your backups, and if you have a standby data center, then you have to have all across how you're going to do that, and if you have different regions, oh, I want to do in this AWS region, and I want to do in that AWS region. I have customers who have, I have my stuff in my main cloud, but I don't want to be locked into AWS, so I also have a standby data center in Azure, and if I ever want to move, that way they pay double for everything. Double in AWS and double in Azure. So, you know, people like that, so, okay. But usually that's what your stack is going to look like. It's not just a database, it's not just your storage, it's all of those things. If you need a production stack, you're going to need all those things. So, and all of these things they have their own things to be configured, their own attack vectors. Storage, you know, being crucial to databases is an important one, because everything relies on that. So if you can't write to your storage, there's not much you can do at that point, besides, let's make sure that I don't lose data. But you usually stop accepting connections, and then your application starts failing, and then you're like, oh, okay. You know, somebody's getting woken up. So the simple view is not really realistic in a production environment. It's basically what I'm trying to say. So all of these questions, you have to think about them in your stack. And if you have good software, it'll set this up for you. But you need to understand, even in cloud environments, so cloud is great. You push a button, things show up, and you're like, oh, great. Yeah, but you know, you win some things, you lose some things. So you have to weigh those pros and cons, and usually there's a lot more money involved. So externally, you have usually your database host behind some sort of firewall or some isolated, you know, network, some VPC, and your applications and users are within that dome, just, you know, talking to it. But the external factors that go into database security is what happens before authentication, what's the physical security of these components, what's the network security around it. So even in cloud environments, you can have your database secured, you can have your application talking to it securely, but then it's taking data and dumping it into some public S3 bucket. Well, okay, your database is secure, but your data really isn't, so at that point, then you have these side-away attacks. What happens if you take your backups, you have your database really secure, but then you put your backups and you don't encrypt them? Then your database is secure, but your data isn't. Again, so it's just different ways to attack the problem. So you have to think about the security of all these different components. And in these days, you're not really running anything, well, most people doing things these days, they're not doing bare metal anymore. Everything's virtualized. You're doing a VM on Proxmox, or you're doing a VM on AWS or Azure or GCP. So there's virtualization attacks as well. So there's some pretty nasty ones that have been disclosed recently. So we can say, well, it's not my problem, it's the cloud provider's problem. But be aware that they do exist, and you do have to have a mitigation plan in place to avoid being caught by surprise. So who can authenticate to the database? So remember the principle of least privilege? It applies to IP ranges and also users and roles. So we'll get to that in a second. But in Postgres, when we talk about users and roles, they're kind of the same thing. It's just that a user is a role that can log in. So you can have a role, and a role is just like it's like a name. And that name can have different permissions. But a role is just a name. And a user, it's just a name, but it has the login permission. So that's usually what a user is in Postgres. So it's important that you keep in mind that who you're going to authenticate with to the database should have as few privileges as possible. So have a very low user, a very low level user with minimal privileges, and then add things that need to be added. But you can have, so your application, usually your application has some sort of, has a user and then they need a connection string and it connects to the database. But really you should have a separate user that has privileges to modify your database. So your application shouldn't be creating tables and dropping columns and those things. You should have another user that has some sort of CI/CD pipeline that, okay, I'm going to apply changes, I'm going to drop this table, I'm going to add this column, I'm going to rename this, I'm going to create these objects. So your application should just be doing reads and writes. And if you can, have a read-only user that's for parts of the application, it reduces your exposure. So segment your user so that they have the privileges that they need, but not anymore. The super user, should be avoided. In reality, in practice, people really don't. Usually they rely on the Postgres users to do a bunch of things, but just like doing everything as root, that's a dangerous thing to do. You can just blow things up and it's not going to ask anything. It's like, okay, drop everything? Sure, I'll do it. It's the equivalent of rm-rf/, sure. If you're root, go ahead, I'll do it, So avoid the super user. These days in Postgres, you can use TLS for everything. It's really built in and really easy to set up. Even if you have your own certification authority, you can issue your own certificates, and Postgres can verify all the way up. So it has really good support for TLS all across the server and the client libraries and everything. So use TLS. Okay. So once you have your users and you have your roles figured out, well, which users can connect to which databases, where can they connect from, so which IP ranges or locally, can they use an unencrypted connection? You shouldn't. You should make sure your connections are encrypted. And which authentication methods can I use? So in Postgres, this is done with the HBA.conf file. If you're in a cloud provider, if you're in AWS, then you have your security groups, but it's basically the same thing. But I didn't want to go, let's go all cloud or let's go all bare metal. So I'm talking Postgres in general, and the principles apply. So your environments, if you're using something like RDS or what do they call that in Azure? Azure SQL? So adjust accordingly, but it's going to have the same thing. So you can set up your connection. So in this case, I'm saying that a local connection, this guy can connect to all the databases with this user, and the method is peer. So peer means it's really relying on the operating system. So it's saying, hey, operating system, is this guy really Postgres? If the OS says, yeah, it's like, okay, I'll let him in. So, you should avoid it, but I'm just putting here as an example, and these are defaults. When you get to the IP connection, so IPv4 or IPv6, that's when you get to the more interesting things. So in this case, I'm saying that you can connect as host, which means an unencrypted connection to this database, app1, with this user, but only locally, and using the authentication method scram SHA-256, which I'll get to that. I'll talk to a little bit more in a minute. But this guy with the plus means he really uses a group. So every user in that group can authenticate from the localhost and IPv6 with SHA-256. And this is an example of a SSL connection. You're only allowing SSL connections. I wanted to bring this up as well because this is new in Postgres 16, which was released like 2 weeks ago, I think. But you can have regular expressions now to match database names and usernames right in the pghba.com. So that's nice, because then you don't have to just have a lot of entries. Like I work with customers who are banks who have hundreds of users, and they had to list like lots of users, like what's this, what's that, and you can do includes and all that, but it's still with a regular expression makes it easier to work with a lot of users. So in this case, this is a remote connection on this CIDR, and again using Scram SHA-256. Many companies deploy some sort of directory solution. So Active Directory is a popular one. Free IPA is an open source one. So, and I've seen this mistake many times where people just have Active Directory, which is basically LDAP with Kerberos, but they only use the LDAP portion. So they use it, they have their machines on Windows and they log into the domain, which is using Kerberos, but then they're like, oh, I don't want to use my database, I want my database to use LDAP. But you really shouldn't. Like LDAP authentication is really not secure for databases, so avoid it. So I have this good, bad, and ugly there. So LDAP is in the bad. It's fairly easy to eavesdrop on your passwords. There's a bunch of workarounds, and you can try to make it more secure, but it's really not very good. Kerberos is really like the gold standard for secure authentication, so it's a little complicated to use in the beginning. There's some concepts like ticket granting tickets, ticket granting service, and ticket granting ticket service. There's all sorts of different concepts that you have to learn, but once you do, things work really well. You never have to pass passwords around. You can just pass these tickets around, and you can verify the whole chain. So it really is secure. So if you have Active Directory, and if you have a database, then just have it use Kerberos on Active Directory, or free IPA for that matter. You can use SSL certs or TLS certs. I just put SSL there. I forgot that one then. So you can have your client authenticate with a TLS certificate straight to Postgres. You can verify everything. The whole connection is encrypted, so that works really well as well. And don't use Trust or PAM. I mean, PAM, it's pluggable. You can plug in different modules, but so it's really going to be as secure as whatever modules we're using and how configurable you left your config up to. Password is really clear, and MD5 and ident these days you shouldn't use anymore. So a note about Scrum SHA-256, it's a big improvement over MD5. It does not reveal the user's clear text password, and it's designed to prevent replay attacks. So there's a feature called channel binding that you have to pass an extra flag on your connection string or an environment variable that it's really meant to prevent man-in-the-middle attacks. So I put a link to a blog post that talks about it in detail by the guy who implemented it, Jeff Davis. So you shouldn't be using MD5. You should be using Scram SHA-256. And if you can, use channel binding. So don't use MD5 anymore. It's been the default for a couple of releases these days, but a lot of people still have those files there using MD5. So, okay, so we talked about authentication and what can the user that's connecting, what can they see and what can they do? And that's the role. And I just put the whole syntax for the create role command here. You can just say this user is going to be a super user. You can have login. It can have create databases. You can have a bunch of things. So basically, you create a role. And again, a role can be a user or it can just be a role. In Oracle, if you guys worked with Oracle before, those are separate things. A role is a role, a user is a user. But in Postgres, there's the same thing. But I wanted to highlight this one because a lot of people don't think about it. But the default, when you create a role, so if you're creating a user, you're creating a role with login privileges right here. But the default is no connection limit. So if you have an application, so you created an application, you created a user that the application will connect as, and your application gets hacked. Somehow you have some vulnerability, and the default is unlimited connections. Well, all your attacker needs to do is create lots of connections to the database. It's going to run out of connections, and your other applications they need to connect to the database. They need to connect to the database. They're not going to have any connections left because there's a limit. There's a max connection setting, and you say, "Oh, I can only have up to max 500 connections." And I've seen people just go crazy and say 50,000 connections, even though it doesn't have any physical capacity to support that many connections. So don't do that, because at least in Postgres, the number of max connections, Postgres uses that to calculate a bunch of things, like how much memory should I allocate for every connection. So by just making your number bigger, you're allocating more memory than you need, just for no reason. But Postgres, oh, he wants more connections, so yeah, I'm going to give it more memory. So don't do that. Be realistic about how many connections you're going to have with a buffer, but don't just like pull a number out of places you shouldn't pull numbers out of. 100,000 connections. Don't do that. Don't. So, and think about the realistic limits of, oh, I have this application, it needs this many connections. So take that into consideration, because if you hit that number, maybe there's something you need to evaluate in your application. Maybe you need to give it more resources. Maybe this is doing too much. Maybe I need to segment it. Maybe I need to make it connect to a replica. I need to have separate into read-only connections to talk to my standby, and have the read-write talking to the primary only. So, but you know, you could DOS yourself if you just leave the application unlimited connections. Postgres has a bunch of built-in roles that you can use, so you can grant, if you grant these roles to a user, it's going to have some permissions. So PG checkpoint, create subscription, database owner. So those are like pre-built permissions, pre-built users. So they, you know, the documentation talks about them, what they actually do, each one of them, but you can create your own, of course, but these are built-in ones. Create roles with appropriate permissions, all these database objects, grant them to the specific users, and remember that grants can be column-based, so you can do, I'm going to grant access to this column to this user, but not to that user. And when we get to row-level security, I'll talk a little bit more about that. But these are some examples of grant commands. So I can grant select on this table to this guy, like a read-only role, or I can have insert, update, delete to the read-write role, execute on function, select, you know, a bunch of things. But this is what I was talking about, that you can grant select on this column, update on this column, on this table to a role. So you can be pretty granular permissions. So this is the discretionary access control that you can have in Postgres. You should resist the temptation to just make a user be a role be a super user. There's a temptation like, oh, I need to do this very complicated set of things, and I don't have time to figure it out, so I'm just going to make it a super user. Avoid that. So if you have a situation like that, a workaround that you can do is you can create a function in Postgres with secure the definer in the definition. And what that means is the user who created the function, when another user executes that function, it runs with the privileges of the user who created it. So it's like doing sudo on a function. So that function can do a bunch of things with elevated privileges, but only that function. And the regular user cannot modify that function. So that way, you can give elevated privileges without having to, you know, grant them, you know, wholesale to the user. And there's some caveats. You have to be careful to not shoot yourself in the foot. So there's some security warnings in the documentation. I put a link there. So here's an example. So if I create this function, insert sensitive data, so if it's this user, insert this data. If it's not this user, permission denied. It's it's a very simple example. You could do that with another way, but here's the security definer thing. So the default is not security definer, it's security, I can't remember now the term that it uses, but the default is not that. So the default is to run with the privileges of the user who's executing them, but this one makes it so the user who created it, it runs with his permission. So if you create it as a super user, it has all permissions, so be careful with that as well. Understand your chain of objects and permissions. So you have the database cluster, it's really called a cluster. Then you have a bunch of databases. Within each database, you have a schema. By default, it's the public schema in Postgres. And within the schema, you have tables or relations. And you have functions, and you have views, and you have different things. So all of those different things, all these levels have permissions. You can have permissions to the cluster, you can have permission to the database, to the schema, to the table, or to the view, or to the function. So all of those need to have appropriate permissions to the users that you're working with. So you understand that chain. Postgres also has row-level security. It's been around for quite a while. Our CTO is the one who implemented it, Stephen Frost. By way of comparison, MySQL doesn't have it to this day. It's kind of funny. You only do that row-level security in MySQL with views. But row-level security really is fine-grained access control. So I can create a policy in a table and say, this user can only see these rows. So all the other rows become invisible to this user. They don't even see it. They don't even know it's there. So you create a policy, and it allows the user to do that. So you use it alongside grant and revoke. But here's an example. So I start being Postgres. So I'm here as a super user. I create a policy called security clearance on the table called hero. And I say, well, PG has role, which is a function. If this user has the clearance member, then he can access. So, sorry, the column called clearance, right? So in my table hero, when I describe it, it shows that it's force row security, and it's using the policy security clearance. So that means, and I didn't want to make these slides too long, but you can look it up. That means if I have a certain clearance, or if I have that permission, I'm going to see certain roles, but a different user. So Dan's not going to see the same roles as I do. So you can go really fine-grained with different policies for your data. And then, so that was all discretionary, and you can get into the realm of mandatory access control, which is SC, PGSQL, so they're SC Linux bindings. It's role-based enforcement and covers most database objects, and you can combine with other SC Linux policies for really, really powerful control. For those of you who are into the government space, there's a STIG for Postgres that Crunchy sponsored, and he keeps it up to date. There's quite a bit of work that goes into that. So STIG is Secure Technical Implementation Guide. It's a comprehensive guide for secure configuration. It's all open source. So the United States Defense Information Systems Agency coordinates all of those, and I put a link to a blog post that announced the latest STIG. Other companies have it too. But Crunchy's has been around for quite a while. So if you need to work in the government space, you're usually going to have to implement that. And Crunchy has several customers who are in that space who need all of that and do. So what about data on disk? You can have transparent data encryption. Proprietary products like Oracle have had it for a while. In open source Postgres, it's still a work in progress. Stephen Frost, David Christensen, David Steele, they've been working on it for a while. But there's a lot of hooks that have to modify into the database, and there's always like, oh, we shouldn't do this, we shouldn't do that. If you follow the hackers mailing list, there's always like disagreements of how things should be done, so it keeps getting pushed out on, pushed forwards into the future. But it's getting movement. Crunchy has a TDE product, but we can't make it open source yet because, if you need to encrypt things in the database, there's an extension called PG Crypto. It's not very practical. There's PGP, there's SSL, there's some hashing. But I had a customer who was using PG Crypto, and he was doing PGP, basically calling a PGP function to encrypt some data and then stuff it into the database. But he asked me, how do I save this key in the database? Like, don't do that. Like, well, why not? It's like, because you're putting the safe and the key right next to each other. You shouldn't do that. And for like half an hour, I couldn't get him to understand why that wasn't a good idea. I was like, no, I just want to put it in the config. It's like, yeah, but if you put it in the config, you can access through SQL. It's the same thing. Oh, but nobody's going to know that I put it there. I'm like, okay. So after like an hour, like, okay, here's how you do it. But it's really a bad idea. Don't do that. But what? 10 minutes. Oh, okay, thanks. There's an extension called Postgres Anonymizer, which lets you anonymize data. It's quite interesting. So you can create a policy that says, for this user, mask the data, or for this other user, give the real data, or for this other user, create fake data. So if you have first name, last name, social securities, so it's really quite nice. So it's another extension. And outside of Postgres, of course, there's the operating system and the storage device, your cloud storage, how are you doing with encryption and those things. So just remember, you have to take care of that. You can't just ignore it. Super user. Well, I'm going to rush through a little bit so I don't have time for questions, but the super user can really bypass most security measures that you have in place. So there's an extension called SetUser that you can basically stop using the super user, and you can grant elevated privileges like sudo within the database, and it gets logged. So if a user does a sudo, quote unquote, with the SetUser extension, then you log what he did with elevated privileges. So it's quite nice. So you can pretty much disable the super user. So I don't know if you guys noticed, but how many of extensions I've mentioned, PG Crypto, SetUser, PG Anonymizer, there's a bunch of them. That's one great thing about Postgres. Once it allowed extensions to come into existence with hooks into the database, there's been an explosion of extensions, and you can do all sorts of fantastic things without ever modifying core, and you can just distribute our extension separately. So logging, we get to the logging part. Who did what and when? Ship it somewhere else. Don't keep it in a database server if you can, because you can fill up your disk, and then instead of having data, you have logs, and then you can't write data. Or outsource it, Splunk, Datadog, all those things. So have a sensible logging policy. One that I don't like to do is log connections. So by default, people say, user connected, user disconnected, user connected, user disconnected. So you have a bunch of logs filled with stuff that you don't care. So look for your logging policy. There's several parameters in Postgres configuration that you can change. You can log statements. Do I log alter tables? Do I log all statements? And be aware in production, if you do that, you're not going to run out of disk space probably. PG Audit extension, another fantastic extension that we ship it by default, but it gives you very detailed session and object logging. Who did exactly what and when? And it can produce audit logs required for compliance. So if you're in a space where you need PCI compliance or other sorts of HIPAA compliance, then PG Audit can give you those logs. What else can go wrong? Lots of things. Keep the server up to date to the latest minor release. A lot of people don't do that. They have policies like, oh, we can't update unless it's every 6 months. At least in Postgres, the minor releases are always, they never do any data changes. They're never backwards incompatible. They're always, so you can safely upgrade your server to the latest minor release, and you get bug fixes. And sometimes they're important ones. So keep it up to date, plan for downtime and plan for updates, otherwise downtime is going to happen to you. And remember, the extensions, they're great, but they have their own release schedule, so if you rely on an extension and there was a vulnerability on it, you have to update it. Ecosystem software also needs to match, so if you're using Patroni, PG Backrest, PG Bouncer, they have their own version, then they can say, oh, this version requires this new feature. And usually they're backwards compatible with, the last few versions. The Postgres policy is 5 releases. So 16 was just released, so 16, 15, 14, 13, 12. So the last one gets dropped. So keep your database up to date or you're gonna run out of security fixes. And again, I mentioned this at the beginning, don't delete wall files. And don't forget backups. Dan, my good friend Dan there, said, well, I put on this slide, database dumps are not backups. They're not for a simple reason. You can't pick the time. So you're not gonna do database dumps every minute. You're not gonna make dumps every hour. Well, maybe you are, but maybe you have once a day. But okay, what if somebody dropped a table right now? You don't want to go back a day. You want to go back to the minute that table was deleted. So that's plenty of time recovery, and database dumps are not going to do that. And then what about your configuration? What about, those different settings? So really what you want is full backups. They're really two separate operations. So they're restore and recovery. But have a documented procedure for restoring backups that you actually exercise. If you have backups, but you haven't exercised your restores, you really don't know if you have backups. Because when fit hits the shan, and you're like, oh my gosh, we have to restore the database. What do we do? It's like, well, I don't know. That guy left a year ago. Well, what do you do? It's like, well, I don't know either. So it has to be documented, and you have to have exercised. Otherwise, what could take you 5 minutes is going to take you a day. So make sure that those procedures are up to date, and make sure that, okay, let's restore this here on my replica. Let's restore it on my dev environment. But exercise your restores so that you know what you're doing. And use specialized software like Backrest. PG Backrest does backup encryption, there's multiple repositories. You can write to S3, to Azure, you can write to all sorts of different backends. It has very advanced features like Delta restores, file bundling, block incremental, and I put this reminder there that the last words heard in the operations room, I thought you did the backups. So don't forget your backups. And then, really quickly, because people, I said I would talk about databases and containers. And should I run Postgres in a container? Well, you are. If you run a plain Linux box, you're running a container, just one single container with full resources to the whole machine. But here's an example where you have this PID, and you can see all the namespaces and C groups that we have. So it is a container. Every Linux machine is in a container, well, modern Linux. Crunchy has an operator that orchestrates everything Postgres related. So you can give it a YAML file that says, I want a Postgres instance with a replica or 2 replicas, and I want it backing up at this schedule, and I want my monitoring here, and it spins up all sorts of containers talking to each other. In like a couple minutes, you can have a fully backed up HA Postgres cluster, and you can make it go across data centers. So you can have it with metrics, but it pretty much instantiates this entire thing here and quite a bit more. And we have very large customers running many big installations with hundreds of databases all day on Kubernetes. So it works well. You just need to have the right skills within your team to manage a proper Kubernetes cluster. So yes, things can go wrong in containers, and they often do. Sometimes people forget. It's like, oh, I have Kubernetes. I can just spin up 1 million pods. Like, well, so over-provisioning is a problem. Making sure that your control plane is set up correctly is a problem. No monitoring is a problem. Your storage, it's still, you still need those resources. And I put some things here about container resource limits, that a friend, colleague came up with. It really works for how you hook up your database to it. I think I'm getting to the end. So I'd like to acknowledge some people who helped me in this presentation. So Greg Mullane is a colleague, and I borrowed heavily from a presentation that he did internally a short while ago. Also, Joe Conway, who's also a Postgres contributor. All the people at Crunchy Data who helped. The amazing Postgres community. My friend Dan there, one of the best ops guy in the state of Utah. Crunchy has quite a few tutorials. If you want to learn Postgres in your browser, it's quite interesting. If you look at it, can I click on that? I have to do this. Yeah, there you go. But if you look at it, it has all sorts of tutorials that you can run right within your browser. And if you click on one of these things, I can dismiss this. But you can see that it's actually loading Postgres right here on my browser. And I can look at tables. I don't know how the guys did it, but they did. I wrote a few of these tutorials, but there's many of them these days. But you can run Postgres right in your browser, try different things. There's lots of material here. Advent of code, that's Greg's as well. So there's quite a few. Let's see, can I go back to that? Yeah. There's a lot of other things on Crunchy Data developers and on PGpedia. PGpedia is a fantastic resource for all sorts of Postgres. So I think I have like 2 minutes left. So thank you. Let's see if you have questions.